Okay, this is section 3.3. I thought I would work some problems and post them. What do you think the number of the runway is pointing due south? Okay, if it was pointing due south, it would be like this. It looks like it goes 0 to 9, and if you had an arrow going down like this, that would probably be 18 there. So 18 is what they're looking for on 34. On 35, it says due west. If it was due west and we're counting by nines, 9, 18, another 9 would give us 27. Okay, so it looks just like they're counting by nines all the way around there. In what ways are the numbers, are the airport runways related to numbers on a circular protractor? Okay, so if you had a protractor, if you look at it, if you turn this thing sideways, I guess, your protractor does go from 0 to 180. If you're looking at it flat, like this part that I just drew in red, from 0 to 90, that'd be about, I guess, if you had like something here that would be 4.5, because it'd be halfway in between. If you think about it, on a protractor, that would be a 45-degree angle. So if I'm looking at these red drawings here, just trying to figure out what they might mean, and also taking a peek at the answer key to see what the answer is, helped me figure out what they were trying to get at here. This is a 45-degree angle, but this would be 4.5 on a runway, okay? So it looks like 45 degrees becomes 4.5. You would divide the number by 10, and remember, dividing by 10 is the same thing as multiplying by a tenth. So they're a tenth of the angle on a protractor, basically. If you were to measure a 45-degree angle on a protractor, you would call that 4.5 on the runway. Again, looking at the answer key can help you when you get stuck. That's what I do when I get stuck and don't go, what are they getting at here? Okay, that's why I provide it to you, because sometimes I need it. Airplanes sometimes take off from either end of a runway depending on conditions. If one end of a runway, okay, we know a runway is going to run horizontal. Let's say one end of the runway is 5. What do you think the opposite end might be labeled? Okay, if they're counting by nines, well, let's see, if they were counting by 5s here, let's say this would have been 0, 5, 10, maybe this would be 15. And if they're counting by 5s, if we're trying to figure out what they're, what else could be going on here, because if you look at the answer key, that's not the answer. The answer key says 23. It says 50 degrees plus 180 degrees is 230 degrees. So they didn't really make it clear, but what they meant here, and again, you wouldn't know that unless you look at the answer key and try to figure it out. If this is 5 and the other end is 180 degrees, and so 180 degrees, if you divide 180 by 10, you get 18. So if I add 18 to get from 5 to over here, since this is a 180 degree angle here, a tenth of it, again, using the information on problem 36, a tenth of that would be 18. So if I say 5 plus 18, this would become 23. That's what they're getting at if you look at the answer key. They're still saying, okay, I'm going to number this 5. It's 180 degrees over there. And if you use problem 36, a tenth of 180 degrees is 18. So 5 plus 18 would be 23. Okay, on number 38 on section 3.3, two runways in an airport may have the same number, such as the ones in the photograph. And if you look on page 96, one runway says 25L and one says 25R. And it says, what does the numbering indicate about the directions of the two runways? The numbering indicates the directions are the same. It's just that they have two runways numbered the same number. Okay, so the directions are the same. They're basically two parallel runways is all that's saying there. Okay. 29, what angle do these runways make with due north? Make a drawing to illustrate your answer. Okay. If you had 25 here, and if you're thinking about the fact that 25 would be like, if you multiplied by 10, it'd be 250 degrees. Okay, so here's north. Let's draw a little coordinates axis here. Here's north. This would be 90 degrees. This would be 180 degrees. And remember, they put 25 on the runways, but the number is just a tenth of the degree measure. They don't want to have to write out that much, so they just cut a 0 off the end of it in a way. This would be 270 here, so 250 would be somewhere between 180 and 270. It's actually going to be closer to 270. So it would be something like this if you were to draw it. I can't draw it just without the axis. To me, putting the axis in and numbering the 90 degrees helps me a lot, okay? So that's what I would suggest you might try to do. And again, this is not going to be on a test. These are just thinking problems to get you thinking about real-life applications of places you might see protractor angles, okay? What do the letters represent in the picture? Well, they're the left and the right runway. L stands for left, R stands for right, okay? So there are two parallel runways that run left and right. Okay, so for number 48, units of angle measures, they measure smaller. There are units of measure of angles that are smaller than a degree, and they're called minutes. 1 minute is 1/60 of a degree, okay? 1 second would be 1/60 times 1/60 of a degree. So we can measure really small increments of a degree. Like if you're thinking about those runways, you would have a lot of in-between measures if you wanted to. This would be 1/3600 would be a second. It says 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. This is what we're saying. These are just unit conversions. Like you might have an hour is equal to 60 minutes and a minute is equal to 60 seconds. Degrees are the same way. They use the same 60th, and that probably traces back to the Babylonians who used base 60 as their measuring system. 48 says, what unit besides the degree also is equal to 60 minutes? Oh, 60 minutes for 48. What is 60 minutes? It's equal to 1 hour. They're just trying to get you to see the relationship here, with a minute being equal to 60 seconds. They're talking about an hour there. If you look at 48, that's all they're talking about. They're just trying to get you to see there's a connection between the way we measure pieces of degrees and pieces of hours. Okay, and then 49 is the last one in this section. How many seconds are there in 1 degree? Well, I already answered that above. If there's 60 minutes in 1 degree and there's 60 seconds in 1 minute, there's 3,600 seconds in 1 degree. It's just like think about hours, how many seconds are in an hour, same idea here. Okay?